quick way of me finding the cycle in this list using the tortoise and hare. Not only will we trying to find detective D to see if there's a cycle in this list, we're going to find the exact node where the cycle occur, the exact node where the cycle meet up again. So at first, this is what I was doing. I was taking the edge case of if there is only one element in the array, or if there is no next, if there's only one list node, and if there is no list node. So if not head or not head.next, that means there is only, that means there is no, either no head or there's no next node. This, I mean, only one node on the other list. So we're going to return true because we can't have a cycle with only one node or no node at all. Return false, actually. So if that's the case, if that's true, then go forward. So if this mean, if we get past this statement, that means that we have more than one node in the list, more than one node, so two node. So while slow, so I'm going to initialize two things here. So the slow pointer is going to be pointing to head, and the fast pointer is also going to be pointing to head, right? And from here, while slow, while we are in slow, I mean we are we're going to traverse the list until we find until we get to the very end. The fast pointer, actually, why don't we move fast here? Because the fast pointer is going to go first. When the fast pointer hit the end of the list, that means there is no cycle. So now while fast, so slow equal to slow.next. That means we're going to increment the slow pointer by 1, and the fast pointer is going to move twice the speed, fast.next, because if we move them at the same speed, the problem is they're never going to meet up. But if we move them at a different speed, eventually, if there's a cycle, they're going to meet up. So now, if we want to make now we have to do the condition to see if they ever meet up. So if slow equal to fast, that means their two nodes is the same. We're going to return true. That means we detect a cycle. If not, we return false. And that is, I think, that's what I did initially for just detecting the cycle. And of course, there's an error when you get to the very last node and there is no cycle. That can throw an error, so we can just do like a question mark here, because it doesn't matter, because on the next iteration, right, it's going to be null anyway, and it's going to break out the list. Because this is an optional chaining. So if the next node exists, it's going to return the next node. If not, it's going to return false. So if this is return null, that means this is not true. If slow has a value to slow and fast is null, they're not going to return true. And because fast is null, it's going to break out this loop and return false. So that's how I used to do it. Nowadays, I just delete this and modify this to do the same thing, because this is basically checking to see if there's a head, if there is more than one node, and there's one node. Well, this condition is already checking to see if there is one node existing. So now all I have to do is search for fast.next here, and that's going to get rid of this true condition for me. And it doesn't really matter, because fast.next is that mean we got to the very last node, right? And there is no more next to this. If fast can go past 4, let's say 4.next is null. Right now fast is null, right? Fast is null, and fast is null, but we're still at 4. If there's no fast.next, that means we got to the very last node, right? We got to the very second to last node. That means there is no more cycle of this node. Because if there is a fast.next at number 4, point back to this to another node, then it's going to the cycle begin again. But we can stop the node before the last node, and that should work just fine. Because if there's a cycle, then okay, I'm rambling on. So that's what I'm saying. Delete that, and we're going to return true. But this only detects to see if we have a cycle or not. Like, it doesn't detect to see if there is where is a cycle, right? To do that, what we can do is that we can loop from the beginning of the list again, and then loop from the meeting points of these 2 points, right? So let's say they meet. Let's say the slow and fast pointer. This is slow and fast pointer. The slow move 1, the fast pointer move 2. So it's fast pointer at 0, right? The fast pointer move at 2 again, and then once again the slow pointer move to 0. The fast pointer will now 2 go to 4, and then it's back to 2 again. And now we go to 2, go to 0, go to 4, -4, And then, okay, why don't I just print it out? Why don't I just try to print this out and show you what I'm talking about? Okay, why don't we just print out console.log fast.val and slow.val. See where they meet. Run for this condition. They should meet at -4, I think. I'm not sure, but that's according to my logic. I don't think it's gonna let me console log it out. Yeah, -4. That's my logic, because 1, 2, right? 1, and then slow pointer is 0. 2 to 1 again. This is where the slow pointer is. The fast pointer is probably now at pass forward to go to 2, and now fast pointer is going to increment by 2 again. So 1, 2 by here, and slow pointer is going to go from 0 to 4. So that's -4. So now to meet at -4, what we can do is that we can increment. We can have another pointer pointing to 3, right? Inside this while loop. What we can do is we can have while here. We can have another node that starts from the beginning of the list, head, while cn. Now that we detect we are in this and we detected the cycle, we can just loop through and find it if cn equal to head equal to slow, which means we find the meeting point of the 2 pointer. Then we're going to return console log dot cn dot val. And now we can just increment both of them by 1, and then they should meet. So I'm going to cn.next and slow equal to slow.next. And that should give me the meeting point of the 2 point, which is number 2. Okay, that didn't work. Cn.next, what is going wrong with this? Let's go to slow. And then we're going to break out of this loop. Otherwise, we're going to continue forever. And that should console log 2. Yeah, 2. See? So that's... It's because... How would I explain this? Because the fast pointer is moving by 2. That means that's it be going half the speed. We will meet at where... the fast pointer would be. I don't exactly know how the math work out on this one. I think it's just very interesting, because if the fast pointer is moving at 2 times the speed, well, yeah, because if one object is moving at and then the speed is faster than another object, eventually they're gonna meet up. But this part right here is what I'm trying to wrap my brain around. How is initializing a pointer from the very head and incrementing it until we meet up with the slow pointer? Well, how would that work eventually, right? I just don't know who came up with this algorithm. It's insane who came up with this algorithm. Maybe it's have to do with the rule of 2 or something. Interesting. I'm gonna look into that later on tonight or tomorrow. Have a good night. Bye.